Okay, welcome back again. Let's understand some more about 4.2 because we don't quite know enough to really understand what's going on. And I'm going to try to hold my breath while I'm underwater here and try to make it all the way through the Zoom without surfacing for air. Okay, so I told you about sine and cosine. This is one of these blue boxes in the book. And remember, we use the cosine to find the angle. What's t? That's another thing. Instead of using theta, they use t for the angle. Most people like to use theta. Once again, wait, t could stand for theta. What's theta? Remember the funny little symbol? That's a Greek letter, theta. In case you're going to go, wait a minute, I'm getting confused. What's all this theta stuff? Okay. Theta, okay. Yeah, maybe they use a t for that, right? That's the symbol, and we use that to measure the angle. Some people draw that for angle for short. Right? Just a little picture of an angle. Okay, but there's some other ones. Tan, that's for tangent. And this one, and this one, and this one. Okay, so what are all these? And up here's the words. Okay, sine, cosine. And did you know this means complement of the sine? Okay, we'll as we go on, we'll learn some patterns and stuff. Tan is for tangent. CSC means cosecant. This is secant. Okay, that's the complement of secant. In fact, here's the complement of the tangent, the cotangent. So what are all these? And they gave some little rules here. Like this is x and y. Tangent says y over x. Tangent is this answer over this answer. Oh, or the y over the x. And these guys are the same as these upside down. So I put on my sheet here, this makes a little more sense. Okay, now the calculator only has 3 buttons, doesn't it? Sine, cosine, tangent, that's it. Okay, so we start with those. You go, well, how do I do the others? Don't worry, you can. Okay, so sine says y over r. R is the radius, but what are we going to make the radius? Make life easy. Let's make the radius 1. Okay, make it 1. So you don't have to worry about it. Cosine is the x over 1. Tangent's the y over the x. Okay. These ones are these upside down. In fact, sine is 1 over cosecant, or cosecant is 1 over sine. It's just flipped over. You could say r over y, but just whatever this answer is, if you want this, just turn it upside down. If you want secant, just take cosine upside down. If you want cotangent, just take tangent upside down. You can memorize that these go together. Like, it's easy to remember cotangent goes with tangent. This, SEC, kind of looks like this spelled backwards. COS, SOC, well, close, SEC. And how do I remember this one goes together? Well, this one doesn't have any vowels. And if a word doesn't have a vowel, that's a sin. Okay, that's how I came up with it. Okay, silly, doesn't make sense, right? Okay, so how am I supposed to do these? Because here's a question. They're going to tell you this. They're going to say, here's a clue. They'll say, let's tell you this piece right here. Okay. They say, here's an angle. Here's an out of focus angle. Okay, there's an angle. And they told me these pieces. Now I could try to find out, well, wonder what angle that is and try to match it up. But that's okay. They want me to list all 6 trigonometric functions. Okay. So let me move this out of the way before I try to do that whole question. That seems like a lot of work. Okay, so let's write all this down and try to get this all figured out. Okay, I'm going to start with this. If we do one question really well, we'll get it. Okay, so here's like some angle again, right? There's theta, right? Of course, we all start over here at 0, right? There's the angle going upwards, and it's got some xy coordinates. So let's put some in here. Let's say, why don't we use 30? Okay, let's use these numbers. So let's say this is a 30-degree angle. Okay, let's do a 30-degree angle, or pi over 6 in radians. Okay, there we go. Let's just use that one. And these numbers here are for 30, and people can actually memorize them, but I'm not going to require you to memorize them, not this year. Okay, there they are. Okay, so now there's 6 functions, and I like to write this pattern because it helps me remember it. Okay, so there's the sine, the cosine, and tangent. People like to write them in that order, and that's the order the calculator did: sine, cosine, tangent. And remember which is which? Let's see. Okay, which one's which? For sine and cosine, well, let's see, this is x and this is y. And x comes before y in the alphabet. So c comes before that one, right? So cosine of the angle, cosine of this angle, right, of 30 degrees. That's the x, right? So we'll put radical 3 over 2. Okay, now I could do it as a decimal. I could go cosine of 30, and I could put that. Let's just put that for now, okay? Because this is exact without having to do any rounding off. Okay, and so I remember this is the cosine, and this is the sine. And maybe some people remember, I remember these rhyme. What do you mean rhyme? Why sigh? Are you sighing? Why sigh? You're doing math, you should be happy. Why sigh? Or it's sci-fi. I don't know, why sigh? Maybe that can help you remember. Y rhymes with I. Okay, so the sine of this angle, the y, is, in this case, it's 1 over 2. Okay, now the tangent. The tangent says y over x. Okay, y over x. Okay, so in other words, tangent is y over x. So I'm supposed to take this answer, the 1/2, and put it over this one, the radical 3 over 2. Now hang on, this is going to simplify. I'll go over here a little scratch paper and go, can you simplify that fraction? Here's a shortcut. Okay. Okay, make sure I got them in the right order. 1/2, radical 3 over 2. Don't put them upside down, 1 over 2. Okay, so 1/2, let me write like this, divided by radical 3 over 2. Okay, let me do this up here a little bit. This will get a little faster in a moment. 1/2 divided by that. Remember how to divide fractions? What do you do to the second fraction? Oh yeah, you flip him over, don't you? Remember that? See, this is why I did it with the fraction instead of the decimal. 1/2 divided by that, right? Now that flips. Now you may remember, oh, of course you make it a times now, don't you? The 2's cancel, and our answer is 1 over radical 3. There you go. And you may remember, people don't like radicals in the bottom. Those stinkers. Why don't they like radicals in the bottom? You go, oh yeah, how do you change it again? Oh yeah, get rid of the radical in the bottom. So let's see, 1 times radical 3 is radical 3, and 3 and 3, well, that's like square root of 9, which is 3. Oh yeah, these cancel out. So radical 3 over 3. Oh, that was kind of a hassle, wasn't it? Now, luckily for you, look what I did here. Wasn't I so nice? There it is, radical 3 over 3. I wrote in the tangents for you, for the popular ones. Yeah, these are the popular ones, 30, 45, 60. And these other ones, these are the popular ones. Okay, so I wrote those in. Most unit circles, if you Google unit circle, you're not going to see that listed. So I was nice enough to list that in. Some people look like this and they say, wait a minute, I see a shortcut. See the 2's? Some people realize, you know what? You just cancel those. And then go, oh, it's 1 over radical 3. And then some people remember the shortcut. He goes to the top and you take the radical off. Now, I could have used my calculator and said tangent of 30. Oh, well, that's the decimal. Okay. Oh, hey, pretty sweet, right? My Casio, see? Casio is just too good. Class whiz, right? Okay. Casio is just too good. Okay. If you did as a decimal, see, it's a little harder to flip. Because if you did it like that, yeah, okay, well, I got the decimal. Okay. So I did 3 of them, right? So the answers, it's going to say, tell me the 6 trigonometric functions. Tell me the 6 trig functions. Now, wait a minute. I've only done 3 of them, haven't I? And trust me, with this question, you're going to be able to do almost all the homework. So we did the sine. We did the cosine. We did the tangent, which is over here. Okay. Okay. Where are the other ones? Okay. Oh. They don't have buttons, do they? Okay, here they are. Now, they're flipped, so I remember this pattern. I like to write these three here, and if you write in this pattern, it's going to be easier to understand. Okay, it's a sin if you don't have any vowels. Okay, I just made that up. And the way you get this, these guys are all flippies. Okay, flip. Take this 1 over 2, 2 over 1. Ta-da! Now, could you do that on the calculator? Let's go back. Sine of 30. Okay, there it is. Do you have a flippy button? I could also put the fraction, 1/2. Do you have a flippy button? Yes, everybody has a flippy button. You do? I have a flippy button. Okay, where is it on this calculator? On this calculator, x to the -1 power. Remember -1? What does a negative exponent do? Go to the bottom. Some people have that button. If you don't have that button, you might have a button that says 1 over x. Okay, I've seen that too. So watch what happens when I press that button. Press, it says answer, flip, 2. Oh, that's 2 over 1, isn't it? Sweet. Okay, so there's your flippy button. Okay, cosine. What word goes with that? Okay, so we got this guy. And cosine, this is when you kind of spell it backwards. This is cosecant. Okay, it's in that little blue chart in the book. Spell it backwards, C-O-S, sock. Well, actually, it's not sock, it's secant. Okay, yeah, I can't see the end, it's a secant. Let's flip this over, 2 over radical 3. Now, wait a minute. That's not in the back of the book, is it? You know why? Nobody likes the radical on the bottom. Remember, a lot of you nerds know, hey, shortcut, move them up to the top. 2 radical 3, then erase. There you go. So there's your secant. Too bad it's kind of an uglier fraction. Now, could I do it here? Watch this. Cosine of 30, 0.86. Okay. There it is, radical 3 over 2. Hit my flippy button. Flip. Okay. Well, there it is as a decimal flipped. 2 radical 3. I'm using this little SD. That's my fraction button. You may have a different fraction button. Your calculator may not be able to do the little fractions, and you'll have to do it on paper. 2 radical 3 over 3. Worked. And the last one, most people have no trouble remembering this one, tangent, cotangent. So we'll flip this. And you know what? Why don't you look back at this one, just flip this guy. Radical 3 over 1. There you go. That's easier, right? Than flipping this and fixing it. That way it's already perfect. If you say, well, what if I flip this? 3 over radical 3. Okay, yeah, you could do that. Where's this going to go? Okay, to the top. Erase the radical. There, see, it's different. Is it? Look. See, you got it, right? And once again, I could have done this, tangent, 30, and I could have hit the flippy, flip, and there it is as a decimal. Well, wait. There it is, radical 3. Okay. Some of you are going to be like, my calculator's only giving me decimals. In the book, they're going to give you all these fractions. Okay, so a lot of the questions are going to be like that. And if you want to see that one again, that's example 1. Can you believe that's only example 1, their first example? And so they wrote them out here. And like I say, if you look at this, you can get really lost in what they're doing. That's my job, to make things easier to understand. Okay. Let's see what else we can do. So let's check out this first question on homework. Okay, the first question on the homework, number 1. Point, this P is for point. A point P, X, Y is shown. Okay, P is for point. Here's the coordinates. Notice negative because it's over quadrant 2, isn't it? Remember over here, the cosine's negative because this is where X coordinates are negative, but the Y is positive, and it says find the values of the trigonometric functions. In other words, they want to know sine, cosine, tangent, cosecant, secant, cotangent. Now, how did I do all that? Okay, so here's what I'm going to do. Okay, it seems a little scary, but you just follow this pattern. And this is a great guaranteed test question, okay? I'm not going to try to ask you the weird stuff, but this is like one of the most important questions. So let's see, we got sine, cosine, tangent. I like to write the pattern. If I got it memorized right there. Sine, cosine, tangent. Okay, now this isn't, I don't have the angle. My calculator is going to be useless, isn't it? Because I don't know the angle. Okay, and let's fill, what are the other guys? What's a sin? Sin is if you don't have any vowels. Spell this guy backwards. SEC, tangent, cotangent, okay. So let's see, sine is the, and if I forget, of course, I know these, but sine is the y, cosine's the x, okay? So here's my little drawing, right? X, cosine's the x, that's this length. Sine is the y, that's his height. Okay, so the y, oh, 8 over 17. That's the y. The cosine is the x. Negative 15 over 17. Okay. Tangent. Tangent is the sine. This is the y. This is the x. Tangent is the y over the x. Okay, so I'm going to put the 817 over the negative 1517. That's why I also like that order, because this comes in the order, doesn't it? Y over x. Cool, it's in the correct order. And little shortcut, if you don't feel like bringing it up and flipping it, you could do that. And then just go, I'll do it in red here. 8 over negative 15. See? Isn't that easy? See, I didn't have to do that whole flip the fraction. Okay, now over here, the other guys. Just this guy flipped over, it's 1 over y. Instead of trying to go, and don't go like this. I see people who don't listen to their teacher, and they go like, well, the rule says 1 over y, and then they go like this, 1 over 8/17. Like, nobody wants a fraction in a fraction. Well, what's the rule? 1 divided by 8/17, right? 1 over that. Okay. Oh, what do you do to this fraction? 1 times 17 over 8. Oh, it's 17 over 8. Well, why don't you just flip it to start with? Oh, yeah, I guess I should listen to the teacher. Okay, 17 over 8. Just flip them over. Same with this guy. Instead of thinking 1 over x, just flip him over. Oh, he's negative. Doesn't matter where the negative is as long as you put a negative. And flip this guy, 8 over negative 15. Okay, I know he's like x over y. See, he's reversed. But just flip him over, negative 15 over 8. So you got your first 3 answers, and here's your other 3. See how easy I made that? There's other ways to think about this. When we get into 4-3, we'll learn more about it. But that's how I crank these out so quick. Here's number 3. Okay, number 3. Well, here's number 2 I didn't do, but look, there's x, there's y. And notice they're negative because they're down here. Yeah. Here's number 3. And once again, see, they're nice to give you fractions. There's x and y. And then you can do the whole thing. There's y, there's x, y over x, then flip, flip, flip. Okay, so now you know how to do the first question. Okay, let's learn how to do the rest of the questions. We talked about these. You could use your calculator or look them up on here, or look them up on here. When you get to 19, it says use even and odd functions. A little confused. Take just same thing. The instructions are more confusing than the work. Cosine of pi over 6. Once again, you can use a calculator, or you can just go pi over 6, cosine, there it is. What's this? That means go backwards. Oh, instead of going, okay. So you can't see that. Instead of going upward, an angle of pi over 6, they say they want you to do a negative pi over 6. Remember negative angles? They want you to go downward, do a reverse negative pi over 6. And go, what's that? Well, I could use my calculator and go cosine of negative and go, what's pi over 6? In case you forget, 30 degrees. Okay, just do it like that. You could just go like that, cosine of negative 30. Now, sometimes the calculator's positive. It's like another section. We get into it. It might not give you the correct angle. Okay, and it's the same answer, actually, because remember, the cosine is the x-coordinate, isn't it? Isn't it exactly the same? In fact, cosines rackle 3/2 if you went upward. But if you went downward, you notice it's the same answer. But if I asked you about the y, see, y is up. Here, y is down. Y's are up and down. Up 1/2, down 1/2. But the cosine's the x. And they're both over this way, aren't they? Yeah, they're both over. So you can still do the same idea. They just say try to go backwards in the angle. And that brings to this. I would use this in the class. Okay, once again. Okay. You see I got this little ribbon? So I made this. The height of the ribbon is the y, isn't it? Right now it's at 0. See, there's 30. Remember, the sine of 30 is 1/2. Did you know, like if you're on a Ferris wheel going up, did you realize you're already halfway to the top? It doesn't look like it, but it is. If I were to take a ruler and actually, whoops, let me try to keep that on 30. If you were to measure this string, I made this, well, let me get a better ruler. This is, trying to get this whole thing in the camera. Okay, this is 12 inches, okay, 12 inches. I say 30 is halfway to the top. That's 12 inches, that's a ruler. If you measure this, of course, you can't read the numbers, but that says 6 inches. And that's why when I hit sine of 30, this is 6 inches. That's half of this, isn't it? Okay. This 6 inches, but you can't really read the numbers on there, is half of that. And that's why on my calculator, when I go sine of 30, it says 0.5. You're halfway to the top. Cool. If I go sine of 10, see 0.17. If you're at 10 degrees, see, you're only a little bit of all the way to the top. The sine is actually kind of telling you this length, isn't it? Which is the y coordinate. But did you notice it's always a number between 0 and 1? 1 being 100%, it's a percentage of the height. So you may have discovered that. Like if you're at, see how the string gets longer and longer and longer? When you're at 80 degrees, like about here's 80 degrees. You see, there's 90. Did you notice the string is almost there? It's almost. That's 12 inches. Isn't this almost there? And that's why when you go like sine of 80, look at that. 0.9, you're 90, you see, you're almost there. So did you see, when you start to understand what the heck's going on here, you're like, oh, so it's giving me like a percentage. Yeah, it always gives you a number between 0 and 1. And of course, if I did the cosine, it's going to tell me how far this piece is in black. Like if I'm at 30 degrees, did you know, like, see, that's right down there. That's almost the whole length, isn't it? The cosine gives me the x. And so that's almost the whole length, isn't it? Because see, here's 12 inches. Look, isn't that like 10 out of 12? And that's why when you go like cosine of 30, it's really just a percentage. It says you're 86%. Yeah, that's 86%. Okay, now with a negative angle, if it says a negative angle, instead of going upward, if you went downward, I'll try not to tangle that up. I know this says 330, but isn't that the same as a negative 30? You could go up 30, or you could go negative 30 degrees, negative 45 degrees, negative 60 degrees. Here's negative 90 degrees. So like a negative 60, the x coordinate is the same as a positive 60. But here the y is positive, but here the y is downhill. Down is negative, right? That is a down direction, okay? In fact, that's why all this down here, the y is negative. Well, up here, the y is positive. Over here, the x is positive. Over here, the x is negative. So everywhere you're at, if you're over here, I got to take the string out and put it in here. And that's why you see a lot of the same stuff. Get that string right through the back. See what I'm doing? Ta-da! And so, like if you did a 210 degree angle, now I couldn't make this slit go all the way, otherwise this would be cut in two, because I cut a line. I want to cut the whole board in two. I had to leave it solid somewhere. When you're at like 210 degrees or negative 150, you see that's like the same as this, as 330. These are the same right here. Right here, is the same as over here, right? Same. A lot of this is a mirror image. Okay. Okay, so as you're going through the homework, a lot of these are really the same questions. They just sound like they're new questions. But once again, you could use your calculator and just do the negative versions of these angles. Or you might have to think about it like, wait, 2/3 pi, negative 2/3 pi. What's 2/3 pi? Let's see. 2/3 pi, oh, 120 degrees. So what's this? Negative 120. Oh, okay. So instead of me going, so if I had to do, where's that? 2 pi over 3, right? Remember, going up, 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 120 degrees. It's over here, right? There's the answers. Where would negative 120? Well, let me think how far I went. All the way to the top and 30 degrees past. So negative 120 would be the same thing. Down 90 and right there. See, that would be the 240. You could have also, remember the trick you learned yesterday? If you had 120 and you're like, what's the other answer? Oh yeah, remember that trick? Either add or subtract 360. That's negative, that would be, well, I don't know, this doesn't really help me out too much. Negative 240, well, let me think of 240. Yeah, I guess that was not a good example. Okay, 240 is the same as the 120, isn't it? Kind of a mirror image. Okay, what else they get? When you get to 25, sounds like a new question again? It's not. It's the same as number 1. You go, what do you mean? What do you want me to do? This question is almost the same as number 1. So let me show you where's 25. They just want me to do the same thing. List the sine, the cosine, the tangent, cosecant, secant, cotangent. And look, they even gave me 2 freebies. Same question. Okay, 29 is a little different. It says, use a Pythagorean identity. And they show me this one right here. Sine squared, cosine squared is 1. It's right here. Sine squared, cosine squared is 1. Okay, so what is this? Okay, so remember the Pythagorean theorem, a squared plus b squared is c squared. If I drew a triangle, a squared, b squared, c squared is a hypotenuse. But let's be trig style, not Gangnam style, trig style. Couldn't we just call this, like this, see, your unit circle, make this your x, and this your y, and this your r? So could we call it x squared plus y squared is r squared? It's the same thing. We're just doing it with, you know, x and y. And what are we using for radius? We said, let's make the radius 1. Let's just make the radius like, that's why my giant wheel, I made it 1 foot. I made it 1 foot long. Let's make it 1. So let's make the radius 1. And what are we using for x? Oh, I know, we're using cosine. Cosine squared, and we have some angle, right? Notice they put the 2 kind of in the middle. That's just the style. And y is a sine, so sine squared. Not sine filled, sine squared. So this is the Pythagorean theorem in disguise. So what am I supposed to do on 25? It tells me the sine is 6/7. So you're going, okay. So I'm supposed to go to the rule right there, and I'm going to take this, and they tell me that's 6/7. Okay, 6/7. Oh, I'm supposed to square, right? And this I don't know. X squared plus that squared is 1. And then I want you to solve it. And now you just do some algebra. And so I wrote it all out here. And remember, this means this. It's just people like to put the 2 in the middle. It's just the style. And there's a reason, but I won't get into it. So sine, cosine. Okay, I put it the other order. Cosine, sine. Does it really matter? No, it doesn't matter. Okay. I still have it, right? 6/7 plus what? And so I did my little algebra. I squared that. And try to solve, get this by itself, right? Move that to the other side, did a little fraction work, and I got that. And then go, the cosine is, what's squared is 1349, so I hit square root. The square root of 13 is, I don't know, the square root of 49 is 7. So you can guide your way through it. So once again, I go, okay, x squared, I just make them an x right now. 1 minus, what is this? Oh, 36 What is that? 49. Okay, so let's call this, if you had a whole pizza and I ate 36 of your 49 slices, I left you with only 13 of your 49 slices. Okay, that minus that. Some people do common denominators, but I just think, hey, got the whole pizza. I stole 36 of your slices out of 49. And then I go, okay, square root. And well, I can square root that. No, I can't. I don't know that. I can square root that. And that's what x is. And should I go plus or minus? No, we won't bother because let's just keep it positive because we squared it and stuff. You can get picky. But I know it's positive because this is positive. What do you mean? Well, if I gave you a sign that's positive, then maybe this is positive, right? I didn't tell you what quadrant, did I? Okay, but yeah, we'll keep it positive. And so that's what some of these questions are. Okay, well, what's this here? And this one, use an identity to find the value. Do not use a calculator. Not use a calculator. Okay, what am I supposed to do here? Well, don't use a calculator. What? Okay, let's see. Sine of 1.7 cosecant of 1.7. What do you mean? What am I supposed to do? Okay, and then I guess these are being times. And I go, wait a minute. Use your knowledge. Aren't these upside down? So you could say, you know what? Cosecant is also 1 over sine. You could flip it upside down. Just flip the whole thing and put the other word. And that's why you see some of these definitions. See right there, 1 over sine. So I wrote all these different ways. Secant's 1 over cosine. Cotangent's 1 over tangent. You could also do this one. Cotangent's cosine over sine. Tangent sine over cosine. Okay, there's multiple ways. And I go, wait a minute. You're on top, you're on bottom. Cancel. Everything's gone. It's gone. Okay. So that's how I'm doing these. I'm doing like, wait a minute, you got flip. Okay, a Pythagorean theorem. Okay. So they give you a variety of ones you get to play around with, and you're supposed to get stuck a little bit. Let's go a little farther. What else do they want to know? This is more of the same, where you can just punch them in your calculator, or you can look them up on the chart, like sine of 3 pi over 4. Sine is the y, radical 2 over 2. Got it. See? Got it. Okay. And then, they want 11 pi 4. And they did part of the circle up here. These ones say punch them in your calculator. Is that degrees? You gotta be careful. I put a warning here. Calculator must be in radians. You know, how do I know it's in radians? Do you see a degree symbol? If you don't see a degree symbol, it's in radians. Radians doesn't have a symbol. Kind of stupid, isn't it? So if I go like this and go sine of 0.8, and I see people do this, and they're like, put that in their test, wrong, because you're in degrees. Oh, is there a degree symbol? No degree symbol. See, degrees have a little temperature thing, degrees. Radians don't have anything. So I didn't get the right answer. I'm supposed to, the book says 0.714. So I'm like, oh, okay, angle unit radian. Okay, I'll try it again. And there we go. Radian, 0.71. Yeah, I got it. Okay. And this is, I'm just going to let you read that. But did you know how, like, in the summer, the days are longer, and the winter, we have less sun? This is the formula. And I'll do this on Friday for fun. But what's cool, this question, I'm going to do this with you on Friday. San Diego. This formula tells you, you put in the day of the year, January 1st is day 1. Put it in any day you want. And this tells you how many hours the sun is out. And did you know it's sine? Yeah, trigonometry is, the world uses a lot of trigonometry. So we'll explain that on Friday. But that's where we're going to stop. So I want you to try the work, and don't forget, you can look at book examples. See, so now you should be able to do 4.2. Hey, I'm on TV. Oh yeah, this is an old-fashioned TV, by the way. And if you look over to the side here, I know I hate to say we, but this is when I was a kid. I had a TV like this, and there's the channels. Look, it only goes up to 13. Yeah, okay. Yeah, that was it. And a lot of them, there wasn't even anything on them. And there was no remote control. You had to turn the knob to pick a channel. So you had to walk over to the TV, and that was it. But anyway, try the homework. Everything builds upon. You do not want to get lost. Like 4.3 assumes you understand 4.2. Okay, that's Thursday. On Friday, tomorrow, we have a review day. Okay, we'll just kind of practice some stuff, and I'll tell you about that cool thing about how many hours is the sun out in San Diego, and why is it that rule. It's actually another section, like 4 or 5, explains that better. But we'll stop there and try the work. And once again, feel free to ask questions in like tutoring.